மாணவர்கள் அனைவருக்கும் வணக்கம். Characteristic equation. Find the characteristic equation of the matrix A with the entries 1 0 minus 1 2 minus 1 5 0 0 2. This consists of 3 row 3 column. So the order of the matrix A is 3. The characteristic equation of the matrix A is determinant value of A minus lambda I. A is the given matrix minus lambda is a scalar. I is the unit matrix with order 3. So we substitute the matrix A and minus lambda. This is the unit matrix. This become 1 minus lambda. We multiply with lambda for each entries of this matrix. So we will get lambda. This is the principal diagonal elements of the matrix. So principal diagonal elements of the matrix is one is called the unit matrix. So lambda, lambda, lambda. So 1 minus lambda, 0 minus 0, 0, minus 1 minus 0, that become minus 1. For this, we get all entries from this equation like this. On the expansion through R1, this matrix is expand with R1. R1 வழியாக எழுதுறப்போ 1 minus lambda into minus 1 minus lambda 2 minus lambda, this becomes 0. All entries minus 0 into 0, all entries, other entries are 0. Minus 1, we here represent 0, so that becomes 0. Only we get these three terms of the equation. Here we simplify this one, multiply on the multiplication of these two terms, we get minus 2 lambda minus 2 lambda minus lambda square. This become minus 2 minus lambda plus lambda square. So we will get the equation minus lambda cube plus 2 lambda square plus lambda minus 2. This is the characteristic equation of the matrix A. Next, Haley-Hamilton theorem. The theorem states that every square matrix satisfies its own characteristic equation. This is the Haley-Hamilton theorem. This is very useful for finding the inverse of the given square matrix. So they give the matrix A 1 minus 1 4 3 2 minus 1 2 1 minus 1. This is also the square matrix with the order 3. Now we find out the inverse of the matrix A. So the characteristic equation of A is A minus lambda I equal to 0. Determinant value of A minus lambda I. So this become on the simplification of the entries 1 minus lambda minus 1 4 3 2 minus lambda minus 1 2 1 minus 1 minus lambda. On the expansion of the matrix, we will find the determinant value of the matrix. We expand the matrix through R1. So through R1 we expand this matrix, we get the characteristic equation. The characteristic equation is lambda cube minus 2 lambda square minus 5 lambda plus 6 equal to 0. By using the Hamilton theorem, Haley-Hamilton theorem, every square matrix satisfies its own characteristic function. For that purpose, we replace lambda by A. We substitute lambda A for lambda. So this become simply we write A cube minus 2 A square minus 5A plus 6. 6 means 6 into unit matrix. So this becomes a single matrix. We replace single matrix, it will give 0 matrix. So every matrix satisfy, every square matrix satisfy its own characteristic equation. For that we write the A for lambda. Now we multiplying A inverse 1, the equation 1 multiplying by A inverse. This become A square minus 2A minus 5I plus 6A inverse. Equation 1 multiplying by A inverse. So we find out 6A inverse. 6a inverse equal to minus a square plus 2a plus 5i. We are write the other terms other than this into the right side. We get the expansion. A inverse equal to 1 by 6 minus a square plus 2a plus 5i. So now find the matrices for this expansion one by one. A square equal to a into a. So this become on the matrix multiplication we get 6 1 1 7 0 11 minus 3 minus 1 0. So the expression minus a square plus 2a plus 5i reduce here 1 minus 3 7 minus 1 9 minus 13 1 3 minus 5. From 2 we get a inverse equal to 1 by 6 into 1 minus 3 7 minus 1 9 minus 13 1 3 minus 5. So this is the inverse of the given matrix A. It is very simple by using the Haley-Hamilton theorem. Now we move the eigenvalue. This is also the important concept: eigenvalues and eigenvectors. Definition: let A be an n by n matrix. A scalar lambda is called an eigenvalue of A if there is a non-zero vector x not equal to 0 called the eigenvector such that Ax equal to lambda x. X is called the eigenvector of the matrix A. It satisfies the equation. This means equation Ax minus lambda. A minus lambda x. This become. So this is the definition for eigenvector. Now we find the eigenvalues and eigenvectors of the given matrix A. This is also the 3 by 3 matrix. Matrix with order 3. The characteristic equation is given by. We must find out the characteristic equation for Haley-Hamilton theorem and the eigenvalue eigenvectors. So this becomes on the expansion of this determinant value of the matrix, my lambda cube minus 7 lambda square plus 0 lambda plus 36 equal to 0. Now we find out the value for lambdas. For that purpose we write the synthetic division. This is called the synthetic division. 1 minus 7 0 36. These are the coefficients of the characteristic equation. Coefficients of the characteristic equation 1 minus 7 0 36. Now we try to find out the value for lambda. We try minus 2. This become minus 2 into 1 minus 2. Become minus 9. Minus 2 into minus 9 18. So this possesses 0. So minus, we decide minus 2 is one of the root of the equation, characteristic equation. So one reduces like this, and also find the another two roots by using these factors. Therefore the eigen values of lambda is this. The value of lambda is called the eigenvalues. The roots of the characteristic equation is called the eigenvalues. So that is important. The eigenvectors x, x, y, z. This is the column matrix corresponding to the eigenvalues. Lambda is given by a minus lambda I into x. So here we are not writing the determinant value. This is the equation. Now we find out the eigenvector for lambda equal to. Now we find out the lambda equal to minus 2. Here we are find out the value eigenvectors when lambda equal to minus 2. So we replace lambda by minus 2 become 3. Here we write minus 2 for lambda, minus into minus plus. So 1 plus 2, that becomes 3. 1 3 Also we are finding all entries of this matrix like this. We substitute lambda for -2. So this possesses the three homogeneous equation. These are homogeneous equation because of all entries of the right hand side are 0. We now find out the value for x, non-trivial solution for x. We find out the non-trivial solution. Trivial means all values are 0. Suppose x, y, z equal to 0, we will get 0 for 3 equations. I mean that x equal to 0, y equal to 0, z equal to 0, all values are 0 satisfy 3 equations simultaneously. But that is the trivial solution. We are not find out the trivial solution, we find out non-trivial solution only. For that purpose we write like this. We are taking 2 equations and also find out the first, this is the first eigenvector of the equation like this. These are very simple. We are studying in the previous classes this method. How to find out, these are ratios. These are ratios. We are minus 20, 20 is also satisfying all three equations. Also minus 1, 0, 1 satisfying this equation. So for this ratio, it will satisfy all the values. I means when we write minus 2, 0, 2 is also satisfy this equation. So these are ratios. So this is the eigenvector of the simultaneous equation. We find out three eigenvectors. So the case 2, when lambda equal to 3, similarly we have to find out the eigenvector of the equation like this. Yeah, this is ratio 1 minus 1 1. Here you watch here, this is ratio minus 5 5 minus 5 is also the solution of this simultaneous equation. The solution minus 5 1 5 the minus 5. But the ratio 1 minus 5 1 is also the solution for this equation. So these are ratios. You can take any one value for these values. I mean that 2 minus 2 2 is also satisfying this equation simultaneously. So this is homogeneous equation. This is called homogeneous equation. This is the non-trivial solution for the homogeneous equation that become called the eigenvector. Now we similarly find out the eigenvector when lambda equal to 5. Here also find out the eigenvector. So the set of eigenvectors for the given matrix is -1 0 1. This is 3 column matrices become vectors. This is the solution. So இந்த அளவிலே இந்த வகுப்பை நிறைவு செய்து கொண்டு அடுத்த வகுப்பிலே சந்திப்போம். வணக்கம்.